Hi, everybody. This is Mr. Corzine. I'm going to go through these notes with you real quick, solving linear systems. Let me get my pen going here. Sorry about that. Solving linear systems. This time, we're using addition and subtraction. There are many different ways to find your solutions given two equations. And here's another trick. This works sometimes. In certain situations, and if you can recognize, I'm going to put that word down too, recognize the situation, it can really help you and save you some time. Okay, so let's just jump right in. Use addition and solve the system by elimination. So what we're doing here is we're essentially just stacking up our two equations, negative 3x minus y equals 8, 7x plus y equals negative 12, and we are lining up all of our terms correctly. Okay, so our x terms are lined up, or over the top of each other. Our y terms are stacked, and so are our constants. And if I get this out of the way, I'll go back to writing. And now I just add all the terms, starting with negative 3x and 4x, or negative 3x and 7x. That makes 4x. And then I have a negative y and a positive y. What does that make? Well, that makes 0. So now I'm left with 8 plus a negative 12, which makes a negative 4. I'm very close to my solution now. I divide by 4 on both sides, and I find out that x equals a negative 1. Now, once I find out that x equals negative 1, I still have to pick out one of my equations. So 7x plus y equals negative 12. I say 7 negative 1 plus y equals a negative 12. Negative 7 plus y, negative 12. I add 7. This is a 12 here, 12. And my solution is y equals a negative 5. Okay, so I have both of my solutions now. X is negative 1 and y is negative 5. All right, moving on. This time we're going to use subtraction. So everything's lined up the same. I've got my x terms lined up, my y terms lined up, and my constants lined up. But this time, you see how the y terms are both positive? I can't cancel those out. If I add them together, I'm going to subtract them instead. So be careful on this one. So be careful here. I'm actually going to subtract a negative 2x. So here I'm subtracting a negative 2x. That means I'm adding 2x. This makes 3x here. Then y minus y makes 0, so that cancels out. And then 1 minus 4 makes a negative 3. Again, look how simple this is now. I divide by 3 on both sides, and x equals a negative 1. Once I know x equals negative 1, I bring this equation over and I solve for y. X plus y equals 1. Now I know x is a negative 1. Well, adding 1 on both sides, I find out that y equals 2. So my solution is negative 1, 2. That's pretty easy, right? The real trick is arranging. That's one of the skills, one of the parts of the process you have to practice. Okay, it says arrange like terms and then solve the system by elimination. So we'll go through this step by step. First of all, we want to arrange the terms. I've got one equation here that is negative 8y plus 6x equals 36, and then I've got here where the x and y terms are switched around. So I'll just rewrite one of them. Let's just go x and y. We'll keep this one 6x minus y equals 15. And then for the other one, we're going to flip-flop these two terms. So it's going to be 6x minus 8y equals 36. And now I have to decide, am I going to add or am I going to subtract? I've got two terms that are exactly the same here. I think these are the ones I want to eliminate. Am I going to be able to eliminate them by adding or by subtracting? Well, since they're both positive, I'm going to have to subtract because 6x minus 6x makes 0. So these will cancel out. But now here, be very careful. I've got a negative 8y minus a negative y. Well, essentially what happens is you end up adding y. So negative 8y plus y makes a negative 7y. Then I subtract my constants, 36 and 15. That makes 21. I go through the rest of the process, dividing by a negative 7 on both sides, and y equals a negative 3. Okay? Once I have y equals negative 3, I can bring this equation down. One of the equations, 6x minus y equals 15. I plug in, I'm going to subtract my negative 3 here from 6x, which is, and that equals 15. That's really a big addition sign, so be careful of that. I subtract 3 on both sides. It's not a 3, that's a 3. That's a little better anyway. And then 6x equals 12, and that means x equals 2. So my solution is 2, negative 3. I hope this is starting to make sense now. You see the process, but you do have to do some thinking, deciding what's best. So decision making, problem solving. It's good. Okay, continue solving by using elimination. All right. Again, I need to rearrange my terms, so I'm going to rewrite this one as a negative 1/2 y plus 8x. That's not x. Equals a negative 38. Sorry for my sloppy handwriting here, guys. And then I have a negative 1/2 y plus 1/4 x equals a negative 7. I have to decide, if I add these two terms together, will it cancel them out? No, it's not going to cancel them out. So I need to subtract them. I'm going to take away a negative 1/2 from negative 1/2, and that's going to make 0. So now I've got essentially 8 1/4 x equals, what is this? Going to be a negative 45. And now I have to decide what I'm going to do here. I think what I want to do is just make this at 8.25x equals a negative 45. And then I have to divide by that on both sides. So I get out my handy dandy calculator here. I could change it into a improper fraction and do things that way and multiply times the reciprocal. Sometimes that works out really great. It gets you to your answer quicker. But I'm going to divide using my calculator. And as it turns out, x ends up equaling 5.45, and then that's repeating. I don't like that at all. So what I'm going to do instead is retry it in a different way. So when I go back and I retry it in a different way, I realize, whoa, hold on a second. I was supposed to be subtracting these two, right? So I'm going to erase this because all the way up here, 8 1/4, when you subtract them, it doesn't make it bigger, it makes it smaller. So I'm going to rewrite this as 7 3/4 x equals a negative 45. And then I'm going to divide by 7.75 on both sides. And let's see if that changes things. So x in this case, if I do 45 divided by, come on, you can. So now when I divide that out, I get something approximately 5.8 or 5.81. At this point, I'm going to say this isn't a great example. And so I'm going to be like, we're done with this problem. I don't like it. Let's keep going. All right, word problem practice. Andy is buying 20 tickets to a play. Adult tickets cost $4 and children's tickets cost $1 each. If Andy spent $32 on tickets, how many of each did he purchase? Set up a table showing the total cost of tickets if Andy were to have purchased 0, 2, or 4 adult tickets. So this is an interesting one that I want you guys to start thinking about. There are several different ways to complete this table. And when we get back together tomorrow in class, we will talk about this. But for now, we're going to stop. You do not need to finish the rest of the notes. I'm going to skip ahead here, and I'm going to tell you that you are going to complete numbers 4 through 28, the evens, on page 447. That's all you need to do for now. And when we get to class on Friday, then we will go over any questions that you have, and we will work on making a table and other ways of doing the same problem solving using elimination. All right, hope you guys have a great day, and we'll see you tomorrow.